Welcome to this virtual HUS Roadshow. I'm David Kavanagh, one of the consultants at the National HUS Centre, and today I will discuss a potential new drug for atypical HUS, Raviluzimab. As you've heard today, atypical HUS is very rare, and we estimate that only about 30 people a year will develop atypical HUS. Historically, patients did very badly, with around a quarter dying and half developing end-stage renal failure. Additionally, because HUS rapidly came back in a transplanted kidney, transplantation was not possible, and the only option was a lifetime on dialysis. The discovery of the role of complement in HUS in Newcastle and the subsequent introduction of Raviluzimab into clinical practice revolutionised patient outcomes. Most patients now recover kidney function, or, if already on dialysis, have a successful transplant. Although this work has been transformative, Raviluzimab has to be given every 2 weeks via drip. This is why Professor Sheeran is running the SETS-HUS trial that we've just heard about to see if Raviluzimab can be safely stopped, and we think that's likely. There will, however, be a few patients who will require Raviluzimab in the long term, and in those patients, a long-acting version of Raviluzimab, may be an option. The complement system evolved to kill bacteria, and there are different pathways which are involved in this, but they all do the same thing. They all result in a rapidly amplifying loop, like a Catherine wheel, which unchecked as an HUS will lead to collateral damage in the kidney. There are multiple molecules that damage bacteria in different ways, such as activating and recruiting immune cells and drilling holes in bacterial membranes. And in HUS, those mechanisms can damage the kidney in the same way. Raviluzimab is a molecule that binds to a protein called C5. And by binding C5, it prevents the downstream complement molecules damaging the kidney. This cured HUS, but currently needs to be given every 2 weeks, which isn't that frequent and is substantially less frequent than most tablets are taken, but it's still very inconvenient. Most tablets are small molecules and are eliminated quickly from the body, which is why you have to take them every 2 to 3 days. Monoclonal antibodies, like Raviluzimab, only require to be given every couple of weeks. One of the reasons for that is that monoclonal antibodies are large and cannot be filtered out by the kidney. Additionally, Raviluzimab and other antibodies undergo uptake by endothelial cells into a pocket called an endosome. If Raviluzimab is not bound to C5, then it can recycle back to the blood. And it does this linked to a receptor called the neonatal Fc receptor. This means that Raviluzimab can hang around the body for much longer. Raviluzimab was designed to bind C5 tightly and will not let go. When this happens, the Raviluzimab cannot be recycled to the bloodstream and is instead broken down in the cell in a process called lysosomal degradation. Because of this, Raviluzimab needs to be given every 2 weeks. Because of this, Alexion took Raviluzimab and tried to make small changes to the molecule to allow it to let go of C5 in this lysosome, which is more acidic. By altering the Raviluzimab molecule, they created Raviluzimab, which lets go of C5 in the lysosome, which allows the Raviluzimab to go back to the bloodstream. And they did this by just mutating 4 amino acids in different bits of the protein. Raviluzimab bound to C5 is internalized into the cell. The pH changes, which allows C5 to be freed from the Raviluzimab and degraded, while the Raviluzimab returns to the circulation and is there for a much longer period of time, which allows for the prolonged dosing you see. This is a diagram showing Eculizumab in purple and C5 in grey. The Eculizumab binds to C5 like this and doesn't let go. In this part of Eculizumab, Alexion altered 2 amino acids, shown here in red, at the binding site for C5, which allowed Eculizumab to let go of C5 in the endosome and to be released into the bloodstream, allowing 8-weekly dosing. One of the questions I'm most frequently asked is Raviluzimab as good as Eculizumab? And the answer to that is, well, we don't really know. There has been no direct comparison between Eculizumab and Raviluzimab, so we can't give you a definitive answer on that. We know Raviluzimab can be given every 8 weeks, and we know it blocks the complement system when it does that in a very similar way to Eculizumab does. There have been concerns expressed about the Raviluzimab trial. There were 3 deaths in the Raviluzimab trial, whereas there were none in the Eculizumab trials. And only about 59% of patients were able to stop dialysis in the Raviluzimab trial, compared to about 83% in the initial Eculizumab trials. And this probably reflects the patients that were put in. We know many patients enrolled in the Raviluzimab trial did not appear to have atypical HUS, because when you looked at the mutation rate in the trial, it was very low. In the Raviluzimab trial, it was only about 20%, and that's very low by historical comparisons. And indeed, if you look at the Alexion Eculizumab trial, there were about 57% that had mutations or factor H autoantibodies. And really, this highlights the importance of personalising treatment to those patients that will benefit most from complement inhibition. So, Eculizumab and Raviluzimab do something very similar. And because of that, they both predisposed to meningococcal sepsis. Neil has already told you earlier today about the high rate of meningococcal sepsis. He quoted about 1,000, and the figures to date in the UK show that there's a case of meningococcal sepsis every 81.6 patient years in somebody on Eculizumab, which is about 600-fold higher than in the general population. Meningococcal sepsis is clearly one of the things we really need to watch out for. There's a very high mortality and morbidity on that, and it's caused by 5 main groups: A, C, W, Y, and B. And because of this, it's one of the key things we need patients to watch out for. From our side, we ask that you're vaccinated with the vaccine against A, C, W, Y, and B, and we're asked that your clinician measures your antibody titers a month to see if you've responded to that vaccine. And if you haven't, then what will happen is you will be offered another vaccine. We also recommend that you carry on antibiotics long term when you're on Eculizumab, because vaccination is probably not enough. We know that from our figures. We also ask that you carry a card round and make you aware that if you're unwell, that you should go to A&E immediately and make the clinician aware that you're on Eculizumab or Raviluzimab. So, where are we with Raviluzimab? Can we use it yet? In America, it has already been approved by the FDA for use in atypical HUS, and the European Commission has recently authorised its use in atypical HUS. In the UK, Raviluzimab is currently under review at NICE, and we expect to hear soon. So, what did I say? I said that Raviluzimab was very similar to Eculizumab. It blocks the complement system in a very similar way to Eculizumab, and it may be as good as Eculizumab in treating atypical HUS. It has the same risks as Raviluzimab, that's meningococcal sepsis, so vaccination and antibiotics are essential. And if you need to stay on Raviluzimab long term, as we've discussed with you, SETS HUS trial, Raviluzimab may be a different option for you. And really, we're waiting for the outcome of the NICE judgment to see whether we'll be able to use this in the UK. I'd like to thank all the team at the NRCTC, and I'd now open the floor for questions. If you've any questions, please put them to us, and we're happy to answer.
Hope everybody stays well.